This is a factory tour of the impact recycling plants in the UK to explain the BOSS and pre-recycling technologies. Newcastle was our first commercial scale plant capable of processing 6,000 tonnes of post-consumer mixed rigid plastic per annum. The mixed rigid material in our yard undergoes a two-stage recycling process. First of all, there's the shred and wash line, followed by the BOSS purification line. We load the loose or baled material plastic into a shredder to reduce the size to 50 millimeters. The shred then pushes through magnets where any metals are removed before it's received by a wet trommel where other heavy items are further removed. The material then moves on to a sink float tank, which separates the technical grade plastics from the polyolefin content. Here we see the material moving on out of the sink float tank and onto the shredder, the second shredder, through a conveyor belt. The second shredder reduces the material down to 10 to 15 millimeters before it is then washed on the right hand side in the grey tank for a further second time. The material is then placed into our BOSS technology, which you can see here. The two brown buckets are feeding the material into the tanks. It's a twin tank system. Here we see the material going up one of the screw conveyors and into the BOSS tank, where you can see the material oscillating up and down, hence the name baffled oscillation. Here you can see the plate inside the tank where we create the whirlpools, which are essential to separate the material into polypropylene and polyethylene. This is the back of the tank where the polypropylene is coming out of the back, a very pure 95% polypropylene. One of the tanks is optimized for polypropylene, the other for polyethylene. Here we see one of the guys just taking a sample from this output of the polypropylene tank and measuring the purity in an alcohol solution, which will show us the number of particles that have risen to the top of the test tube versus the number of particles at the bottom, showing a very pure product. This then material is moved into a bagging system where we have a bag of polypropylene and a bag of polyethylene regrind ready for resale with up to 98% purity and 0% heavy plastics. This is the second stage of what we're doing, is where we introduce the pre-additive to control the melt flow rate, and by doing this we're producing a pellet. So we're taking the regrind that we've produced in those bags, loading into a reamer compounder along with the additive to control the melt flow rate to produce a pellet of the required melt flow. Here are some videos of products that are being made with the pellets that we are supplying to molding companies that are our customers. This one here is a sealant gun cartridge. This requires a melt flow rate of 7. It's an injection molding process, and that's using the same regrind that we use to make this product, which is a bottle for shampoo or for other hair care products. So this is a blow molding application. So you can see the material coming out here on the right hand side. It's very stiff. It needs to be stiff. It needs to have a melt flow rate down as low as 0.5 so that it doesn't lose its shape when it's blown into the mold on the left hand side. Otherwise the bottle that is blown would collapse into itself. So there you have two really distinctly different products, one with a melt flow of 7, the other with a melt flow of 0.5, but both coming from the same base mixed melt flow material. Here we have a product we make for Berry Group. It's a 200 litre water drum that you'd see outside in your backyard. Again, this is a blow molding application. It needs a very stiff melt flow rate, so the melt flow rate is low at 0.5, and here you can see the material, the product coming off the line. And the two products on the right with the stickers, that's our product compared to what they were producing before from taking in old material and recycling it directly into what it would have been, so old watering cans. Here we are seeing the colors that are possible. We can also recolor through the additive that we have developed to those colors that you can see there. This is our product, this is our plant in Glasgow. It's a 15,000 ton facility. It takes in mixed medical waste, which is predominantly made of paper, and flexible material and rigid material. So it's particularly difficult to separate out those three distinctly different types of material because they tend to bind together. This plant is more modern than what you've seen in Newcastle. It has a higher capacity. We moved into this in 2022. Newcastle was in 2018. Here we have our own Arema compounder that you can see now, that machine, the grey machine. And here we're just looking at the same BOSS systems that you looked at in the Newcastle site, just from a different angle. I won't go through the same process, but essentially because the paper is heavier than the rigid and flexible plastic, we can separate that. And then once we've separated out the paper, we can further separate out the rigid plastic from the flexible plastic. So this is just an overview of the machines as the material is passing through the Boss systems. And then we have an output from that, which would be a flexible plastic flake, which would then pass through the piping systems to be fed into the silos on the left here, the big tall silver silo on the left, which then leads to the Arema compounder on the right hand side that we can see now. So from the Arema, we're then dosing that material, which is LDPE flake, with the MFI, the melt flow rate additive, which controls the melt flow rate, which allows us to make a waste bag from that LDPE, from the flexible plastic we're collecting. And here we can see the pellet being produced. So this would be an LDPE pellet with a melt flow rate for blow molding applications, for extrusion blow molding applications. This is the rigid box that we're able to make from the rigids that come from that Glasgow line. It's actually a waste bin that the NHS used to collect medical waste. So it's a truly circular application. And here's just an example of us blowing films from the pellet that we're producing. This is with the client that does this. We supply them with the pellet. They're making rolls of black waste bags. They're only 12 microns in thickness, so that's the thinnest bag that you can see, which would typically be a bag that you might pick up in an office where you have very thin bags into the waste bins, because there's very little load going into them. It's obviously easier to make thicker bags, like agricultural bags, but we've been able to achieve this thickness, showing us that we can make any film. So here it is coming off the line, the roll of bags, typically sold in Aldi or Lidl or Tesco or wherever. And here you can see the application, and up close you can see the quality of the bag that we're able to produce. So that gives us a product that we can sell, take in flexible material and produce flexible material from it. The third plant that we're looking at is a plant that is funded with debt from Nestle. It's a new plant that should be open in August 9th, 2024. It's going to be taking in 25,000 tons of household film, and we're going to recycle it into consumer film. At 25,000 tons, it's the largest of our plants to date. It will use the Boss 2D technology and the melt flow rate additive technology to produce a LDPE pellet capable of being blow molded into a waste bag. This is the typical feedstock we will take in, bales of flexible film. And finally, we have the development we're embarking on in Helsinki in Finland in 2024, should be ready in December 2025 with Ciclo. It's for two 25,000 ton recycling plants, one for film, one for mixed rigids. It's a €50 million investment into the site, €15 million in